So let's jump into the first model of the course. And this is going to be a model that sort of encapsulates the entirety of software production. It's something called the WRSPM model, or for short, the World Machine Model. And what this model depicts is the interaction between the environment and the system. And this is important because you have to understand there are a lot of different aspects that go into a piece of software. There are a lot of different things that you might not think of that you have to think of when designing a piece of software. For example, whenever you have an application on your computer, you have to have an input and output device to communicate with that application. So for example, if we're using something like photo editing software, to actually edit the photos, we not only have to do the program itself, but we also have to have the hardware that it runs on, which is going to be your personal computer. And then you have to have input devices. So for example, a keyboard and a mouse. And then on top of that, you have to have the human being that actually interacts with all of that and understands how to use it all. So this is a way of categorizing that so that we can look at the requirements of a system and see if we're missing anything. To sort of look at it and are we missing an assumption that we are supposed to make? Is there a particular element that we're not taking into account? It just allows us to put those into to the right place. So then, the left side of this Venn diagram is something called the environment. And this is where the system is going to be operating in. Think of, for example, an ATM is something that is used quite often to categorize this. So for example, we have an ATM machine here. And if you live in another country, it's a money dispensing machine. I know different countries call them different things. In America, it's called an ATM, automated teller machine. Basically, you go up to it and you get money out of it. Pretty simple. But you got to think that this ATM, it's working in the world, the sphere of the world. And then there's a program inside of it. There's a little program running. And then it connects to something outside. Maybe it goes to a big server or banks or something like that. But there's all these different elements that go into it. So the left side is the environment. What is our system working in? And here we have two different sort of areas or two different things that we look at. And the first one is W. And the W is, you'll see that we're going to be going through all of these letters here, is world. It's the W right here. So the world, this usually comes down to assumptions that we have to make whenever we're making a software. And these can be really, really sort of simple and almost quote unquote stupid assumptions, but they need to be made. For example, with an ATM, one of the world assumptions is that there's a bank on the other side that has money, that there's a purpose to this ATM, that there is an entity that is actually keeping track of these transactions, and therefore the ATM has purpose. So one of the assumptions might be that there are banks, that money exists, that their money is a sort of an entity. Now, of course, you might not be able to come up with, a better way to design your program with that assumption, but by putting the assumption in there, you start understanding the program just a little bit better. And then you get to things that are important, like the ATM we have the assumption that the ATM or this machine is always going to be connected to electricity. Now that's an important one because you might be thinking that you want to put it into a city that has maybe not the best power grid. Maybe it turns on and off every 30 minutes. Maybe it, 1 or 2 days a week, it has a power outage of an hour or more. That's an assumption you got to think of. Okay, do we want the ATM just to shut off? Do we want it to have a backup battery? Do we want the program to reset? What do we want to do with all of this? And so that is very important whenever you are sort of going over this stuff, is to understand these assumptions so you don't miss any requirements. And that's the next part, is the requirements. So the system is sort of this side of things. And before we actually build the system, we need to understand in a conceptual idea, what are we building? What is this system doing? What's the purpose? What is it trying to accomplish? What problem is it solving? And so that's where the requirements come in. That's part of the environment, because the environment has created a problem. The environment has generated a problem, whether it's just a passive problem, something that we think, hey, this could be fixed, or whether it's an actual problem, something where we're something that maybe humans generated or that over time society has created, and therefore we create our requirements. Then the next step is we get into sort of the blending between the environment and the system, and that's where we get into specifications. So we put the S right here. Specifications goes over the sort of the fine details of the system. So we're still in that environment thing. We're still in solving the problem. However, we're also building the system. We're also determining what the best thing for the system is. We're getting technical details out of the way. So this is where the two blend. We're actually building, this part is a lot of times referred to as the interface. We're building the branch between the environment and the system, the terminal for connecting the world to this program. And that, of course, leads us to the next one down here, which is program. And so now we're into the system. So the program is the code itself. The program is what's executing. It's the if-else statements. It's controlling the hardware. It's grabbing the data. It's sending the data. That's what the program is. There isn't anything too advanced on that, but it's sort of the biggest part of software development is actually creating the program. And that's why we're going to be talking about that basically for the rest of the course. And then finally, we have the machine. And this is important because we need to understand what hardware is it running on. The machine is the ATM itself. It's the actual entity, the RAM, the CPU, the networking cables, the internet service provider servers. It's all of that stuff. It's the physical entity that the program will be running on. And this is important to know because maybe we developed a program that needs to use an internet that's, I don't know, maybe 100 megabytes per second. And we realize that not anywhere carries that internet for an ATM. So we need to rework our requirements. Maybe we need to add a requirement where it has to be below 10 megabytes per second. Things like that. And so that's just important to consider throughout this. Now, there's also another little category in here. And we kind of create these other little circles like so. And what we have with this is we have something called EH, EV, and then we have SV, SH. And so what these are they just mean environment hidden, environment visible, software visible, and software hidden. So environment hidden, environment visible, software, or system visible, system hidden. And what these are is they just sort of determine a little bit more of sort of classifying the environment. So with the environment hidden, we have things like ideas and pieces of data that a human knows. For example, a EH would be a PIN number. That's a piece of data. It's a concept. It's something that we need to incorporate. However, it's hidden. It's not actually going to be available to the user. It's not posted on the side of the ATM. It's something only a human being knows in their mind. Therefore, it's an environment variable, which is hidden. Then we have environment visible. An environment visible is the things that are actually exposed to the real world. Whenever you actually enter that PIN number into the system, it now becomes visible. It becomes quote unquote stealable. Someone could look over your shoulder and take that. So a lot of times environment visible is the data that's actually entered. It's those sort of those concepts in your mind when they're actually entered into the system. And then you have something known as system visible, and this is pretty simple. It's the visible parts of the system. It's the things we interact with. On a computer, that would be the keyboard and the mouse. On an ATM machine, it's the place where you insert the card. It's the pin pad. It's the ways to go through it. So this is the sort of the outside of the interface, the way that we connect with things. And that's why you can see that this is all part of that interface here. We have data that's coming out of the abstract, which means like not concrete. It's just information stored in our minds or maybe on some other device coming into the interface. And with that, we enter it into the visible part of the machine. So this is, the visible part of the machine. So for example, it would be that little area where you enter things in. And then we have software hidden. And software hidden, or I keep saying software, but system hidden is the back end. It's that RAM inside. We don't need to know the inner workings of an ATM. We press a button, the ATM inner workings do what they're designed to do. Same with a lot of software. If we grab two sides of an image, let's say we're editing in an image and the image looks like this, and we want to rotate the image to the right. We click whatever button is in our software that, maybe has like that arrow button on it, and it rotates. We don't need to know the code that goes into that. We don't need to know it taking all of the ones and zeros and applying a formula to it and doing all this stuff. That's the hidden part. The system visible is that button that we can hit. And so those are, again, things that you want to consider whenever you're creating these variables. It's just these requirements or the sort of problem scope is you just want to understand what's the environment hidden, What's the environment visible? What's the system visible? What's the system hidden? If you're making a really big piece of software, these things are vital to understand the fullness of the problem. So next lectures, we're actually going to be going, we're going to keep diving into this. So let's keep going.